Hey guys, and welcome to Functional Print Friday, and welcome back to my shop. So I usually work on these videos in the evenings after work, and I happen to be away all this week on business, and I was flying back, and I was trying to think about, what am I going to do this week for a video, and I happened to be watching some other YouTube videos on the plane, and I happened to see this clip in someone else's video.
These are really nice for plumbing and wiring. I'd like to share this with folks. It's a rare earth magnet with a loop on it for a zip tie to go through. So you can just stick it to the body of the frame, put a zip tie on there, and you're good to go.
So when I first saw that clip, my first thought was, I got to get some of those. I didn't even know those existed. And I like the idea that they're reusable as well. Now, he goes on to say that they're about $1 a piece, which, isn't super expensive, but if you want 15 or 20 or 50 of them, obviously that's going to get kind of pricey. And while the magnetic base is reusable, you're still snipping the zip tie every time that you want to, reposition one, or reuse it for something else. And one of the reasons I liked that design is that you can cinch the zip tie on it, so the wire can't slip through it either. So if you're trying to temporarily route a wire and you don't want to have any slack in it, they'd be great for that. But again, even to move it on the wire, you're snipping that zip tie and using another zip tie. It's also sometimes tough to snip those zip ties on real thin wires without damaging the jacket on the wire either. So I thought, wait a minute, I think we can make this, and I actually think we can improve upon the design. So I was thinking, what if we had a cylinder as a base that had a magnet in it, and it was threaded, and we had like a cap tighten in on the wire, and we have like a slot through it for the wire to pass through, that you put the wire in place and then thread the cap on. You could tighten it down on the wire to keep the wire from slipping through, and to get the wire out, you just simply unthread the cap, take the wire out, and you can reuse the whole thing. So in the early stages of me designing something, I will often just grab my digital calipers to just kind of help visualize the size of something. And I think the size of this probably around, I don't know, maybe 15 millimeters. That's probably a good size. I don't think I would want to go smaller than that. And another thing that I will often use when I'm designing is this. This is a set of tools that's designed to figure out what thread something is on either the inside or the outside bore. So they're threaded on the inside and they're threaded on the outside. And these are not that expensive. I will link to the one that I have. I'll warn you, there's sets of these that look almost identical to this that are colored. Don't buy one of those. They're anodized aluminum, and aluminum tends to gall and or be damaged if you're using it in steel. This set is stainless steel, and for whatever reason, this set's actually cheaper than the aluminum ones. It'll often help me just visualize what thread I want on something when I'm designing it. So in this case, let's see, we're saying like around 15 millimeters. So let's see, M10. Yeah, we could probably go bigger than M10. Let's try M12. That's a fine thread though. Let's go to like a coarse thread, M12. Yeah, I think that should give us enough clearance for the threads and still have a nice thick wall. Actually, flip it around. What does this measure? Yeah, it's 14. That's probably enough wall thickness. So we could probably actually pretty much copy sort of this portion. So yeah, this actually helps us visualize it even better. So imagine the base of it, forget about the threads down here. The base of it is basically like this, except it has a slot down through it on this side and this side, so that you put the wire down in there, and then the top of it is basically a cap that's threaded like this. The threads down in and holds the wire. Yeah, I think that'll work. And then, yeah, we could actually press the magnets in. I was kind of thinking we'd have like a bore on the bottom face, press the magnets in from the bottom, but the reality is I have some 10 millimeter magnets. I think that's the biggest I have. Yeah, so the inside dimension of an M12, like inside the thread, so not the outer thread dimension, the tops of the threads to the tops of the threads on the other side is over 10. So we could have a bore at the bottom that was 10 millimeters in diameter to press magnets into, and that should work just fine. So whenever I have an idea like this, one of the first things I'll do is actually just go out and see what other people have come up with, because a lot of things we do in this channel, they are really specific to a certain use case, but this one really not so much. I mean, these I could see using them for all sorts of different things. So I took a look on MakerWorld, and there is a bunch of different designs that are somewhat similar, but none of them are exactly the same thing. This first one, I do like that it's very low profile. So it has just a sort of like a horseshoe shape, shallow, has I think these are 6mm magnets in here. And it looks like they're either just pressed or glued into place. And the thing I don't like about this is there's no way to actually clamp the wire into place. So there's nothing going to be stopping the wire from sliding through this left to right. I would like something that is going to keep the wire from moving around. So for example, if we have plenty of extra wire over on this end and we're trying to keep it away from something over here, I don't want to be able to like pull a loop through and have it hang down. This one is kind of the same concept, but just a single magnet. This looks like this is an 8x2 magnet. Also kind of a neat design, very low profile. Same problem, it doesn't actually keep the wire from sliding through. And with a single 8x2, probably not a tremendous amount of strength for either one of these guys. This one is kind of neat, also pretty low profile, closer to what I was thinking. And it looks like it's designed for a specific wire size. This is a 5x2 magnet, a single one in here. Looks like it's probably pressed in. It's on the build plate, so it's a little hard to see. I'm assuming there's just a bore on the underside of one of these to press the magnet into. And then whatever we size, I guess we would need a design for each size wire so that it kind of, clamps in there and holds. So this one would keep the wire from slipping left and right, which I like, but we'd need a separate design for every single wire. Now, when I first clicked on this one, my initial thought was, oh, this is perfect. This looks like exactly what I was thinking. I don't need to design anything. But this one actually suffers from the same problem as the other ones. And I don't know if that was intentional in their design or not. If we open up the 3D preview, at first it looks like, okay, yeah, so our wire goes through and then we clamp down on the wire with this cap. But if we look at the width of the bore that makes up the bottom of this slot, if we put a wire in that is smaller than this bore, you see the cap is going to hit this, the face of the cap here is going to hit this face here and never tighten into the wire. And even if we put a wire in here that is as wide as this will permit, so imagine a round cross section of a wire, if it fits through the slot down here, it's still not going to extend past this face here, so we're never actually going to tighten down on the wire. Now I thought, oh, I could modify this. I mean, I could adjust the geometry of that slot, bring this up a little bit so that, imagine this curved face down here instead sits up here or sits all the way up here. Maybe we don't have that curved face until down here, so we don't actually have anything through this geometry down here. But if we do that with this design, this outer face here is going to press on the wire on this side and this side on not a whole lot of surface area, and we're going to be pulling it this way over here and pulling it this way over here, which I think has a higher chance of damaging the wire versus doing this in reverse, which is what I was thinking, where we have the base has the female portion of the thread and the top that tightens down is the male thread, and this would be a solid face up here. So we'd be pushing on the wire, clamping it in place with this whole solid face. That should reduce the chance that we damage the wire and also gets rid of our problem of trying to pull the wire one way over here and pull the wire the other way over here. I also don't see any reason to have the knurling on the base. So as close as this was, I think it still makes sense to just design our own from scratch. They also used a small single 6mm magnet, probably working around what they had. There's a lot more real estate here. I want to use the biggest magnet that we can, and we'll put 2 of them in there. We're going to use those 10mm magnets. So, all right, let me get started on the design, and I will bring you guys back. All right, and here's where I'm at with the design for this so far. And yeah, it's incomplete, but there's a reason why. I'll get to that in just a second, but let me show you where we're at so far. So down here at the bottom, we have a bore for 2 of those 10mm magnets to get pressed into. And up here at the top, we have M12 thread for some kind of cap to screw in here to hold our wire in place. It's probably a little easier to understand if I turn on a section cut. Yeah, there we go. So this is the bore down here at the bottom. The 2 of those magnets stacked are going to press into. You can see we have a small gap down here. This is 0.5mm from this bottom face to the bottom face of the bore for the magnets to this bottom face of our actual total part. And that 0.5 millimeter should not affect the magnetic force too much, but will make it really easy to keep the bottom of this guy clean, particularly if we're using it in an area where we're generating, like metal dust or metal chips, something like that. And then up at the top, we open up into, essentially a wider bore with that M12 thread. Now, you're probably noticing we were missing that slot that we actually want to put the wire through. And this is a great opportunity to show you guys how easy it is to modify models that maybe you've generated in a CAD program that doesn't give you the easy ability to do that. It is, in this case, quite difficult to have a nice clean mesh going through threads because there are so many faces on these threads. But let's just say that this is a model that you grabbed off of MakerWorld or Thingiverse, whatever. And it works for you perfectly aside from maybe one small problem. In this case, we want to put a slot through this. So, and that slot is going to extend all the way down to this face down here, basically the top of that bore. The wire should be able to come and pass through a slot here that sits all the way down to where those magnets are pressed into the bore, and then we screw the cap in and hold the wire in place. It'll make more sense when you see it finished. But we can actually do that with some simple objects, in this case, a cylinder and a rectangle, right in our slicer. Let me show you. All right, so as a first step, I've gone ahead and imported that part as an STL here into Bambu Studio. And these steps are going to be the same with Orca Slicer. If you're using a different slicer from Bambu Studio or Orca Slicer, these steps are going to be a bit different, but you should be able to find these features within pretty much any modern slicer. We're going to be doing all this work at the object level. So first thing I'm going to do is click on Objects over here. And you can see we have just a single STL. That is this guy right here. So the first thing we're going to do is add some other pieces that we can work with here in the slicer. So I'm going to right click on this and I'm going to hit Add Part, and we're going to add a cylinder. And by default, it kind of sets it down right next to our first part here. So if I click on this and we check our position, if we just set our object coordinates all to 0, should get this guy down in the build plate centered up in the exact same position as a first step. Now we need to make this guy the right size because remember, we're going to use these other parts that we're adding to modify our original design, this wireholder.stl. So if I click on this guy, you actually got to be really careful here because anytime you click on any part, they're on top of each other now, so it's hard to tell. It selects everything by default. You've got to make sure you have just the piece that you want to modify selected. So I'm going to click here on generic cylinder, and now let's go to scale. And you want to make sure your uniform scale is turned off, and we want to set our X to be 5 and our Y to be 5. That should give us the right dimensions for that slot. Now you'll notice it's not in the right orientation. We can fix that pretty easy. If we just go to rotate, see, we can either rotate this, I guess, in the X or the Y. We want to turn it 90 degrees. Let's do the X. Okay, that is starting to look better, but it is too high. So again, making sure we have just the object that we're trying to modify selected. Let's see, we want to move this. We realistically want the bottom of this to sit right at the top face of that bore at the bottom for the magnets. And let's see, we had 0.5 millimeter and then 5.5 for this bore. So we want this to sit right at 6 millimeters, but the object itself, the coordinates are going to be from the center point. So we need to be that at 8.5, I guess. Let's try that. 0.5. Now that is still too high. You know what? I think we need to actually set that in world coordinates for the Z. Okay, that looks like it's at the right spot. An easy way to tell is actually just to slice it. And if we go down, we can see, okay, there is our top face of that bore. And yeah, the very next layer starts our other part. So that looks good. Now, we don't want just this area down here to be cut out. We want to cut out this area up here as well, but that's okay. We can do that. So if we click on our wire holder again, right click, and we're going to do, actually we got to be up here on the STL, add part, we'll add a cube, and we're going to start by doing the same thing here. We'll set our object coordinates to be 0 on the X and the Y. We'll go to scale, and we want our X to be 5. Yeah, that looks right. Now, it's not in the right spot, but that is okay. We could do it with the coordinates here, but this is one we actually don't need to be that perfect on this. Let's see, Y is, oh, we're still on scale, that's why. So we want to go to move, and I can actually just drag this guy, get just the cube. This is one we can actually do visually. I mean, we could figure out exactly what number we need that to sit at, but you see anywhere sort of in this region here is probably going to do it for us. And this is another one, again, we can verify just by slicing it. And we can see now we have, because the accuracy is only within the line width and the layer height. So we can see that we are right on. There's no steps on either side here. Now I hear what you're saying. That's not what we want to print, Rich. That's not going to work for us. We essentially need to knock out this. Imagine if this was the tool path, and say if we were machining this. So if we go back to prepare, this is where the magic happens. I'm going to click the whole thing. So now we do want all the pieces selected. And we're going to go up here to Mesh Boolean. And we want the difference between two of these parts. So subtract from. This is where we're telling the slicer what part we want to have less of, basically. So we want to have less of this main one down here. So if I click on this, it actually shows us the parts. That's perfect. And subtract with. So this is what part are we using to make the subtraction from? So we're actually going to do this twice because we need to use the cylinder and then the cube as well. So we want to make sure we turn on delete input. Click difference, and look at that. We've already done part of our work here. So we'll just do this again now, subtract from. We're going to subtract from this. We're going to subtract with that cube. We've got our delete input turned on and hit difference. And now that's looking pretty darn good. Let's hit slice plate, just make sure. Yeah, I believe that is exactly what we are looking for. Now, some of you might already be opening up a new comment to tell me that you can do that with modifiers and it is a little bit less work than going through the Boolean operations. And that is true to get you I'm not going to say printable model because it's not really a model. You can print from that, but the magic of doing it this way is you're really kind of doing modeling within the slicer, which allows you to now click this and go to File, Export all objects as one STL. And let's see, here's what we imported, this magnetic wire holder. If we go and we add, call it fixed. Now if we add that, look at that. That's actually an STL. That's not like a saved file here in Bambu Studio that we could print from again. That's actually what the STL now is. It is the modifications built into the model, all as one solid part. So that enables me to share this with you guys. Or you guys, if you're using the slicer to make modifications like this as well, you can actually get that exported as a solid part and share it with other people, and they can print that versus you trying to share your slicer settings and everything all in one shot. It gives you a solid model that you can export. So I have already done the same thing for the cap. So I'll pull that in, and now you guys can kind of get an idea here of how this is going to work. This guy's obviously going to be flipped over. And I'll thread into the top and should then tighten down on whatever wire we're passing through here. And the magnets will press into the bore down here. So another thing worth noting, when you're doing threads like this, I could print them like this and it might fit. It's probably going to be really tight because both these are a perfect M12 thread that has very minimal clearance built in. And if we were interfacing either one of these with another component that was like a tapped hole in steel or something like that, it'd probably fit just fine, or a bolt would probably thread into this one just fine. But because we're 3D printing both of these and these tool paths are not going to be perfect, we're going to need some extra clearance. So I'm going to click this part and we'll go to, let's see, scale. And now I'm going to turn uniform scale on. And we could just do a percentage. I would start with probably taking somewhere between 3 and 5% off. Let's try 96%. And that's just shrunk that whole thing by 96%, which actually, you know what, now that I think about it, we don't want to do that because we don't want our Z to change. That would actually change our thread pitch. So we want to turn uniform off. We want to leave Z alone because think about it, if we shrunk that down here, I'll exaggerate it. Yeah, we have now a completely different thread pitch that's not going to align with this guy. So we don't want to do that. We want to leave that alone. But we do want to change X and Y. That's going to change our clearance for this thread. So we'll make this 96%. We'll make this 96%. Now you can see that has shrunk in the directions that are going to control our thread fit, but it's leaving our thread pitch and the overall height of this alone. So, all right, I think it is time to print this and see if our magnets are a good press fit and see if these parts actually fit together. So it's tempting to print a bunch because I do want more than one of these, but whenever you're printing components that are designed to fit together, don't do that. Print one, make sure it fits before you start filling up the bed and creating a bunch of waste if they don't fit. So I'm gonna do just that. I'm gonna print one of each of these and I will bring you guys back. All right, and our test pieces are done. Let's see how these thread together. It starts nice. It's maybe a little snugger than I'd like, but I don't want to loosen it up anymore because I don't want this to free spin either. Like I don't want this to vibrate off if it's on something that's vibrating like a machine tool. And I actually can't tell if it's bottoming out on the face up here or bottoming out on the face down here. It looks like it's really close, so that's just perfect. And if we open this up, I want to see that we're going to have in the vertical direction as much clearance as we are in the left to right before this falls out. Yeah, that looks like we probably have the full 5 there, and that's still grabbing on. So that should work. It's close though. Actually, that was only like another quarter turn. Let me go grab a couple things to try this with and make sure that that's actually going to work before we keep going. All right, I grabbed a bunch of stuff to try that I could see using this with. So this is one of those like real just thin wires for temporarily connecting something together for testing. Yeah, that fits no problem. Really, I just wanted to make sure that it clamps even a small wire like that. Yeah, that's on there good. The other thing I thought is I could see using this for PTFE tubes, just for kind of keeping your lines out of the way. So yeah, that fits just fine. I'm not actually sure what the OD of one of these is, but definitely less than 5. I wonder how this is going to clamp because the PTFE is so slippery. Ooh, that actually clamps really tightly on there. So that works. This is a piece of Cat5e Ethernet cable. I bet you this is close to 5. Oh yeah, that's the max right there. That's right at 5. That guy doesn't even really rock back and forth. So this is a perfect test. If this threads on and clamps, we're good. Yeah, look at that. Perfect. I don't think we could have sized that any better. We're on like 1.5 threads there. And then this is an oscilloscope probe. I could see using it for one of these. That's obviously going to fit. And this is just a thicker jumper cable. Yeah, that guy's smaller than the Cat. The Cat 5 was right at 5. This is probably 4. That'll work just fine as well. So, all right, I think the only thing we need to make sure now is still good is if we can press 2 of the 10mm magnets down in that board. Let me grab the magnets. All right, here's 2 of the 10mm magnets. Now, I think we could probably press this in with the threaded cap, but it's going to be tricky to keep it straight. So you probably could do that if you're making one of these for yourself, but I have an arbor press, and that I know is going to press this in dead straight. So let's go over there. All right, this is a 1/4 inch punch, but anything metal that is smaller than the diameter of the magnets would work. I say metal because it's nice that you can actually just put the magnets right on it like that and they'll stay in place, especially when we're trying to get them down inside a bore like this. And if we get this nice and vertical here in the arbor press, this will ensure that we're pressing these in perfectly straight. Yeah, it's a nice press fit. It's a pretty good amount of force that holds with too. I think that's going to be good. All right, now that we have the magnets in, let's just try this again with our largest diameter wire. This is right at 5mm, just to make sure we don't have any interference there that I'm not thinking about. No, that still fits just fine. In fact, actually, that's probably, we probably shouldn't have even tested it without the magnets because we were, especially on the smaller wires, it's almost kind of trying to slice them. But now we have a flat bottom all the way across. So that works nice. All right, let me print a couple more of these so we can actually try it out and see if we can kind of route a wire around temporarily on something. So now that we know that everything fits, I want to go ahead and print a quantity of these out. And I'd like to stick with these 2 colors as well. I thought that looked nice, the contrast between the 2. So I want to show you 2 tricks here. And I bet you the first one, almost everyone knows about. Second one, I'm going to say I bet you only about 50% of the people watching this video know about. So first let's clone these. And to do that, we can just right click on it and click clone. And if we hit 4 here, that's going to give us 5 in total. We do the same thing on this guy. Clone it 4 times. Now we have 5 in total. And we can just hit arrange, and that'll clean up our toolpaths so that they're not running into each other. And if we slice this just like this, it's going to change filament 107 times because it's going to have to change for each single layer that it prints in this print. And there's 107 layers because I'm doing this in 0.12 millimeter layer height, so we get nice resolution on those threads. Second trick though, if we go to others here in our settings and we go down to print sequence, by default this is always by layer, and that is typically what you want. However, in this instance, if we make it by object and it can print each entire object in entirety, and we arrange things in such that it can print all of these gray parts and then all the blue parts, it should only have to change filament once, maybe twice, depending on what color it prints the purge line in, I guess. So already now it's complaining that it's too close. Let's see if we go back to prepare. Oh yeah, and it's actually showing us now. So when we do it by object, it's printing the whole object and then moving to print the next object. So you can see in this case, like if it printed this whole object and then went and tried to print this object, the tool head's going to strike this one. And that's exactly what it's showing us with these sort of circles here. I think auto arrange can actually save us here too. Let's see. I think that'll work. It looks like it's going to probably print these first and then these. Let's slice it. It's a surefire way to tell. Yeah, look at that. Filament change times 2. And we just knocked 2 hours off our print time. We can actually see what it's going to do with our preview slider here. So it's going to print all of the blue ones one by one first. And then it's going to print each of the dark gray ones one by one. So not only is that going to save us a whole ton of filament changes, it's going to save us a bunch of waste, but we're also probably going to get cleaner parts. And that is another instance where I will use this, even if I don't have multiple colors. Let's say I just wanted to print 2 of these, and even if they were in the same color, and there's a small part like this, and I know I have plenty of room on the bed to print one in its entirety, move over and print another one, I'll also go in here and switch it to print sequence by object, because the toolpaths completely change the moment you start printing multiple objects on the bed, because it has to leave the object that it's printing, switch over to another object, retract, come back. So all your toolpaths change. The start and stop points are going to be different. If you do this by object and you have room on the bed to move things around, your toolpaths are identical to the toolpath that you have for a single part, even if you're printing a bunch at once. All right, I've got all 5 of these done. Let's use the lathe from last week's video as sort of a prop to talk about an example scenario that we could use these for. So I've got my multi-tester here too, and I've got 2 leads with alligator clips on the end. And let's say that I wanted to, I pulled this cover panel off and I'm trying to attach to one of these switches up here to test something. But I need to test it while it's running. So while this is running, yeah, I'll turn it on. We've got spinning gears, we've got 2 pulleys, we've got a belt, lots of places for these wires to get caught. And yes, I've temporarily overridden the safety switch so that we can operate this lathe without the safety cover on there. Now, I could probably, you know, I don't know, maybe route this over here or something, maybe zip tie this to here, but there's still the possibility that these are going to get sucked in here, which is going to be a real bad day. Give me a second. Let me move the tripod over. Let's see if we can use these to safely route these wires to have this attached while this guy's running. All right, well, that worked out great, but even just this simple test, I've already run out. I really should have had at least 6. You can see the last one down here, I only had 1, and I just kind of have the red wire underneath of it. Should probably have not only 1 here, but probably then 2 more down here as well, where it comes off the chip pan, just here in this example, to ensure that nothing gets sucked into our drivetrain. And what's nice is the wires, they're not just running through these, the wire's clamped in there, so the wire can't slip through there. If I pull on this, you see the entire thing's going to come along with it, and that's stuck on there pretty good. Those magnets are pretty strong. So I'm really happy with this. It's already got me thinking, since these are 10 millimeter magnets, we could probably just order some 20 millimeter magnets and then do 200% or double the size of these for much larger wires, like even power wires off something. All right, I can hear you guys down in the comments telling me to actually turn this on and test it. So this machine runs pretty smooth, but even if this thing was kind of rattling around or something like that, I don't think these are going to go anywhere. They're on there pretty good. Oh, look at that. We did have 6. I forgot about our test one from earlier. So, all right, if you guys want to make a set of these, as always, the STLs for these are completely free. They'll be on my site, fpfdesigns.com. I'll put a link to that down in the description of the video. I'll put links to both colors of this filament as well, and the specific magnets that I used for these. Guys, as always, thanks for hanging out in the shop with me for this week's design and video. And let us know down in the comments if there's anything you would have done differently with this design, or if you've got any questions, or if you're going to make a set of these, let us know what you're going to do with them. There's always such great discussion down in the comments. I often get ideas for new videos from comments. I often get ideas for revising these designs from the comments, and that's all thanks to you guys. And actually, on that point, this channel just crossed 30,000 subscribers, I think this week. I never thought this channel was going to grow that big. So thank you to you guys for watching these videos, and again for all your comments as well. And if this is by chance your first time here on the channel, this is all we do. It's all functional stuff like this. There's no multicolored doodads of the week. It's all functional stuff like this. A lot of design and engineering. If you enjoy that sort of thing, check out some of the other videos on the channel. And if you like what you see, hit that subscribe button. And guys, if you do, I'll see you next Friday.